Okay, so the next example here, 15.5, is a little bit different. So 25 centimetres cubed of 0.02 molar potassium permanganate is pipetted into a conical flask. Some dilute sulfuric acid and excess potassium iodide solution are then added, and the liberated iodine is titrated against a solution of sodium thiosulfate solution of unknown concentration. The average titration figure is 18.7. Calculate the concentration of sodium thiosulfate in moles per litre and grams per litre of crystalline Na2S2O3 So, just going to fill in here what I know. 25 centimetres cubed of 0.02 molar potassium permanganate. So these are the two equations that I'm given in the question. And these will always be given to you. And I'm told that I then react that against some sulfuric acid, which is here, and potassium iodide, which is here. And the liberated iodine here is then going to, is titrated, which is here, against my sodium thiosulfate. And my average titration figure is 18.7 centimetres cubed. And we are asked to calculate the concentration of sodium thiosulfate solution, so this in moles per litre and in grams per litre. So if I look at what I have, okay, it's important here that I'm aware that I have two different equations, okay? And I am looking at setting up my ratio ultimately with MnO4 minus is to S2O3 2 minus. Okay, the only way I can get to there is by I2. Okay, so I have from my first equation 2 MnO4 minuses to 5 I2s, and then by my second equation 1 I2 is to 2 S2O3 2 minuses. That should have been a 2 there. So I have to multiply this second equation by 5. So I'm multiplying the whole lot by 5. So if I multiply the whole lot by 5, 1 by 5 is 5, 2 by 5 is 10. So my ratio here is 2 is to 10 or 1 is to 5. Okay? So that's how we work out our ratio here. Right, just to start, I have 0.02 as a molarity, which means moles per 1,000 centimetres cubed. In this question, I haven't used 1,000 centimetres cubed. I only used 25 centimetres cubed. So I multiply by what I know, 0.02 by 25, divided by the bit left over, which is 1,000, and that gives me 5 by 10 to the minus 4 moles. That's my number of moles of potassium permanganate. Now, in this question, I'm asked for my sodium thiosulfate, and that's where I have to work out this ratio here. So I've worked it out that it's 1 is to 5. So 5 by 10 to the minus 4 moles of potassium permanganate is going to give me 5 times more of sodium thiosulfate. So 2.5 by 10 to the minus 3 moles. And that 2.5 by 10 to the minus 3 moles, I'm told in the question, uses 18.7 centimetres cubed. And in the question, I am asked for it in moles per litre. So again, I multiply by what I know, 2.5 by 10 to the minus 3 by 1,000, divided by 18.75 gives me 0.1337 moles per litre. That's my answer to part A. After that then, I'm asked for my grams per litre of crystalline Na2S2O3 5H2O. So again, I have to work out my relative molecular mass of this whole compound. So 23 by 2 plus 32 by 2 plus 16 by 3 plus 5 into, and it's 1 by 2 plus 16. So that's going to be 18. Okay? So remember, always solve inside the brackets first. That's maths and your BEMDAS. So when I multiply this 23 by 2 plus 32 by 2 plus 16 by 3 plus 5 by 18, I get 248. So number of moles equals mass in grams divided by my MR. My number of moles, 0.1337, multiplied by 248 gives me an answer of 33.1577 grams per litre.